In the National Electrical Code, reclamation refers to facilities or areas managed by the United States Bureau of Reclamation. This is a federal agency responsible for managing water resources, particularly in western states. Due to the potential hazards present in these locations, the National Electrical Code contains special requirements for electrical installations in reclamation facilities. Let's explore these specific implications. Firstly, conductive locations. Many areas in reclamation facilities, such as bathrooms, kitchens, and shops, are considered conductive locations due to the presence of conductive surfaces, for example, metal countertops or wet floors. In these locations, certain requirements apply. One such requirement is that ground fault circuit interrupters, GFCIs, are required to protect against electrical shocks. Secondly, metal boxes and enclosures must be grounded. Next, let's consider equipment grounding conductors. Conductive raceways, such as conduit or electrical metallic tubing, cannot be used as equipment grounding conductors in reclamation facilities. Instead, a separate equipment grounding conductor must be installed. The special requirements for reclamation facilities are found in Article 90 of the National Electrical Code. Now, let's examine some example National Electrical Code provisions. For example, reclamation does not permit conduit, cable tray, electrical metallic tubing, liquid tight conduit, flexible conduit, or any other conductive raceways as equipment grounding conductors. This is specified in Article 90.308. A. Bathrooms, kitchens, shops, and most other locations at reclamation facilities are conductive locations and therefore require GFCIs. This is specified in Article 90.302. B. It is critical to adhere to the special National Electrical Code requirements for reclamation facilities. This ensures the safety and proper functioning of electrical installations in these hazardous locations. Failure to comply may increase the risk of electrical shocks, fires, and other accidents. Let's delve deeper into understanding conductive locations within reclamation facilities as defined by the National Electrical Code and the specific requirements they entail. Conductive locations are areas where individuals are likely to come into contact with grounded metal objects or wet surfaces, increasing the risk of electrical shock. These locations necessitate enhanced safety measures to mitigate potential hazards. The presence of conductive materials and moisture significantly reduces the body's resistance to electrical current, making even small electrical faults potentially dangerous. In bathrooms, for instance, metal faucets, shower heads, and wet floors create a conductive environment. Similarly, kitchens often feature metal countertops, sinks, and appliances that can become energized in the event of an electrical fault. Workshops, with their metal machinery, tools, and concrete floors, also pose a heightened risk of electrical shock. To address these risks, the National Electrical Code mandates the use of ground fault circuit interrupters in conductive locations within reclamation facilities. Ground fault circuit interrupters are fast-acting devices that detect even small imbalances in electrical current, quickly interrupting the circuit to prevent electrical shock. When a ground fault occurs, meaning that electricity is flowing through an unintended path to ground, the GFCI trips, cutting off power to the circuit in a fraction of a second. This rapid response minimizes the duration of the electrical shock, significantly reducing the risk of serious injury or death. In addition to GFCI protection, the National Electrical Code also requires that all metal boxes and enclosures in conductive locations be properly grounded. Grounding provides a safe path for electrical current to flow back to the source in the event of a fault, preventing metal surfaces from becoming energized. When a metal box or enclosure is grounded, it is connected to the earth through a grounding conductor. This connection ensures that any electrical fault current will flow safely to ground, tripping a circuit breaker or fuse and de-energizing the circuit. Proper grounding is essential for preventing electrical shock hazards and ensuring the overall safety of electrical installations in conductive locations. Now, let's shift our focus to the requirements for equipment grounding conductors in reclamation facilities. As previously mentioned, the National Electrical Code prohibits the use of conductive raceways, such as conduit or electrical metallic tubing, as equipment grounding conductors in these facilities. Instead, a separate equipment grounding conductor must be installed. This requirement is in place to ensure a reliable and dedicated grounding path for electrical equipment. Conductive raceways can be susceptible to corrosion, loose connections, and other factors that can compromise their ability to effectively carry fault current. By requiring a separate equipment grounding conductor, the National Electrical Code ensures that a dedicated grounding path is always available regardless of the condition of the raceway. The equipment grounding conductor is typically a green or bare copper wire that runs alongside the circuit conductors within the raceway. It is connected to the grounding terminals of electrical equipment, providing a direct path for fault current to flow back to the source. This dedicated grounding path helps to quickly trip circuit breakers or fuses in the event of a fault, minimizing the risk of electrical shock and equipment damage. The size of the equipment grounding conductor must be appropriate for the size of the circuit conductors it serves. The National Electrical Code provides tables that specify the minimum size of the equipment grounding conductor based on the overcurrent protection device protecting the circuit. These tables ensure that the equipment grounding conductor is capable of safely carrying the maximum fault current that the circuit may experience. Furthermore, the equipment grounding conductor must be properly connected to the grounding electrode system of the facility. The grounding electrode system typically consists of ground rods, ground plates, or other conductive elements that are buried in the earth. This connection to the earth provides a low impedance path for fault current to flow back to the source, ensuring effective grounding. The National Electrical Code also specifies requirements for the installation and routing of equipment grounding conductors. These requirements are designed to minimize the risk of damage to the grounding conductor and to ensure that it provides a reliable grounding path. Now let's consider some practical examples of how these National Electrical Code requirements apply in reclamation facilities. In a bathroom within a reclamation facility, all receptacles must be GFCI protected. This includes receptacles for hair dryers, electric shavers, and other appliances. The metal enclosure of the bathroom's lighting fixture must also be properly grounded. In a kitchen within a reclamation facility, all countertop receptacles must be GFCI protected. This includes receptacles for small appliances, such as blenders, toasters, and coffee makers. The metal housings of all appliances, such as refrigerators and dishwashers, must also be properly grounded. In a workshop within a reclamation facility, all receptacles serving power tools and equipment must be GFCI protected. The metal frames of all machinery and equipment must also be properly grounded. In all of these locations, a separate equipment grounding conductor must be installed within the raceway, ensuring a dedicated grounding path for all electrical equipment. It is important to note that these are just a few examples, and the specific National Electrical Code requirements for a particular reclamation facility may vary depending on the specific characteristics of the facility and the types of electrical equipment installed. It is essential to consult the National Electrical Code and other applicable standards to ensure that all electrical installations in reclamation facilities comply with all applicable requirements. In addition to the specific requirements discussed above, there are also some general best practices for electrical safety in reclamation facilities. These best practices include regularly inspecting electrical equipment for signs of damage or wear, immediately repairing or replacing any damaged equipment, avoiding overloading electrical circuits, using extension cords sparingly and never using them as a permanent wiring solution, keeping electrical equipment dry and away from water, following all lockout-tagout procedures when working on electrical equipment, providing regular electrical safety training to all employees. By following these best practices and adhering to all applicable National Electrical Code requirements, reclamation facilities can significantly reduce the risk of electrical accidents and ensure the safety of their employees and the public. The National Electrical Code serves as the cornerstone for electrical safety in the United States. Its comprehensive guidelines aim to safeguard individuals and property from electrical hazards. Reclamation facilities, with their unique operational environments, necessitate strict adherence to these codes, particularly Article 90, to mitigate risks effectively. This article outlines specific requirements tailored to the unique challenges posed by these environments, addressing conductive locations, equipment grounding, and GFCI protection. Conductive locations, as defined by the National Electrical Code, are areas where individuals are more susceptible to electrical shock due to the presence of conductive surfaces or moisture. These locations include bathrooms, kitchens, and workshops, commonly found in reclamation facilities. The National Electrical Code mandates stringent safety measures in these areas, primarily the installation of ground fault circuit interrupters. Ground fault circuit interrupters are designed to detect ground faults, which occur when electricity deviates from its intended path and flows through unintended conductors, such as a person's body. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing electrical shock. In addition to GFCI protection, the National Electrical Code also requires that all metal boxes and enclosures in conductive locations be properly grounded. Grounding provides a safe path for electrical current to flow in the event of a fault, preventing metal surfaces from becoming energized and posing a shock hazard. Equipment grounding is another critical aspect of electrical safety in reclamation facilities. The National Electrical Code prohibits the use of conductive raceways such as conduit as equipment grounding conductors. Instead, a separate equipment grounding conductor must be installed to provide a dedicated grounding path for electrical equipment. This requirement ensures that a reliable grounding path is always available, regardless of the condition of the raceway. The equipment grounding conductor is typically a green or bare copper wire that runs alongside the circuit conductors within the raceway. It is connected to the grounding terminals of electrical equipment, providing a direct path for fault current to flow back to the source. The size of the equipment grounding conductor must be appropriate for the size of the circuit conductors it serves. The National Electrical Code provides tables that specify the minimum size of the equipment grounding conductor based on the overcurrent protection device protecting the circuit. Reclamation facilities often involve outdoor electrical installations, which are exposed to harsh weather conditions and require additional safety measures. The National Electrical Code addresses these concerns by providing specific guidelines for outdoor wiring, grounding, and protection against lightning and surge events. Outdoor wiring must be installed in a manner that protects it from physical damage, moisture, and sunlight. The National Electrical Code specifies the types of wiring methods that are suitable for outdoor use, such as underground wiring, weather-resistant cables, and rigid metal conduit. Grounding is particularly important for outdoor electrical installations, as it helps to protect against lightning strikes and surge events. The National Electrical Code requires that all outdoor electrical equipment be properly grounded, and that grounding electrodes be installed in accordance with specific requirements. Lightning protection systems are also recommended for reclamation facilities in areas that are prone to lightning strikes. These systems consist of lightning rods, conductors, and grounding electrodes that are designed to safely divert lightning current to ground, protecting buildings and equipment from damage. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical installations in reclamation facilities. The National Electrical Code recommends that electrical systems be inspected regularly by qualified personnel and that any identified deficiencies be corrected promptly. Maintenance activities should include testing of ground fault circuit interrupters, inspection of grounding connections, and verification of proper overcurrent protection. By implementing a comprehensive electrical safety program that includes regular inspections and maintenance, reclamation facilities can minimize the risk of electrical accidents and ensure the safety of their employees and the public. In summary, adhering to the National Electrical Code, particularly Article 90, is crucial for maintaining electrical safety in reclamation facilities. By implementing appropriate measures for conductive locations, equipment grounding, and outdoor electrical installations, these facilities can create a safe and reliable environment for their operations. Regular inspections and maintenance are also essential for ensuring the continued effectiveness of electrical safety measures. Reclamation facilities play a vital role in managing water resources and providing essential services to communities across the United States. By prioritizing electrical safety, These facilities can protect their employees, the public, and the environment from the hazards associated with electricity. Ongoing training and education for personnel working with electrical systems in reclamation facilities are paramount for fostering a culture of safety and preventing accidents. Training programs should cover a wide range of topics, including basic electrical theory, national electrical code requirements, safe work practices, and emergency procedures. Employees should be trained to recognize electrical hazards, use personal protective equipment properly, and follow lockout-tagout procedures when working on electrical equipment. Refresher training should be provided regularly to ensure that employees stay up to date on the latest safety practices and regulations. In addition to formal training programs, reclamation facilities should also promote a culture of safety through ongoing communication and awareness campaigns. Safety meetings, toolbox talks, and safety posters can be used to reinforce safety messages and encourage employees to report potential hazards. Employees should be empowered to speak up if they see something that they believe is unsafe, and their concerns should be taken seriously and addressed promptly. By fostering a culture of safety, reclamation facilities can create a work environment where employees are committed to preventing accidents and protecting themselves and their colleagues from electrical hazards. Furthermore, technological advancements continue to shape the landscape of electrical safety, offering innovative solutions for hazard detection and prevention. Smart sensors, for example, can monitor electrical systems in real time, detecting anomalies that may indicate a potential fault. These sensors can trigger alarms or automatically shut down equipment to prevent accidents. Arc flash detection systems are another example of technology that can improve electrical safety. These systems use sensors to detect the presence of an arc flash, a dangerous electrical explosion that can cause serious injury or death. When an arc flash is detected, the system quickly interrupts the circuit, minimizing the duration and severity of the event. Remote monitoring and control systems can also enhance electrical safety by allowing personnel to monitor and control electrical equipment from a safe distance. This can be particularly useful in hazardous environments where it is not safe for personnel to be physically present. By embracing technological advancements, reclamation facilities can further enhance their electrical safety programs and create a safer work environment for their employees. Finally, collaboration and information sharing among reclamation facilities, industry organizations, and regulatory agencies are essential for advancing electrical safety practices and promoting continuous improvement. By sharing best practices, lessons learned, and new technologies, these organizations can help to raise the bar for electrical safety across the industry. Participation in industry committees and standards development organizations can also provide reclamation facilities with a voice in shaping the future of electrical safety regulations. In conclusion, electrical safety is a critical concern for reclamation facilities, requiring a comprehensive and multifaceted approach. By adhering to the National Electrical Code, implementing appropriate safety measures, providing ongoing training and education, embracing technological advancements, and fostering collaboration and information sharing, reclamation facilities can create a safe and reliable environment for their operations and protect their employees, the public, and the environment from the hazards associated with electricity. Remember, it is crucial to consult with qualified electrical professionals and adhere to all applicable codes and regulations when working with electrical systems in reclamation facilities.